Hello friends, this is second part of fluid mechanics video on multiple choice question. If you haven't watched first part of this video, please watch it. I have provided the link in the description box. So let us start. The device used to measure the fluid pressure is. So here the device used to measure the fluid pressure is manometer. Thermometer is used for measuring the temperature. Anemometer is used for measuring the speed of fluid flow. Hygrometer is used for measuring the humidity and amount of water vapor. Second, the Pascal law states that the pressure at a point is equal in all direction. So it is equal in all direction with due consideration that fluid is at a rest. So we consider that fluid at a rest, then pressure at a point is equal in all direction. The stress-strain relation of Newtonian-fluid is, we know that Newtonian-fluid obey the Newton's law of viscosity, so stress-strain relation will be linear here. Fourth, a glass bottle filled with a liquid will break at a bottom if the stopper is forced into open end as per. So this is as per the Pascal law. A flow in which each fluid particle has a definite path and their path do not cross each other. Now this type of flow is called as a streamline flow or a laminar flow, in which each fluid particle will move in a straight line and they will do not cross their path. See, a venturimeter is preferred to orificemeter because energy loss is less in case of venturimeter as compared to orificemeter, but the orificemeter is a cheaper, more convenient to use. Which method is most commonly used in fluid mechanics for analysis? So here Eulerian method is most commonly used in a fluid mechanics. So for description of fluid flow, Eulerian method is used. In case of Eulerian method, the pressure, velocity and acceleration is measured at a point in a fluid flow. In a steady flow of a fluid, the acceleration of any particle is. So steady of flow of a fluid means that the velocity is going to remain constant at any point. If the velocity is constant, acceleration is nothing but rate of change of velocity, means here rate of change of velocity is 0, so acceleration will be 0. In case of a flow through orifices, the coefficient of velocity at vena contracta is. So vena contracta is a portion where area is minimum and velocity is maximum. So here orifices is nothing but the small opening. So the coefficient of velocity at vena contracta means the value of CV is always less than 1. So the value will range from 0.95 to 0.98. The value will be 1 if there is no friction in a fluid flow, which is not possible in actual practice. So the coefficient of velocity at vena contracta will be less than 1. Its value will range from 0.95 to 0.98. The steady flow occurs when conditions do not change with respect to time. Condition means pressure, velocity, acceleration will not change with respect to time, or fluid properties will not change with respect to time. Due to variation of venturimeter constant, the venturimeters are suitable for. So the venturimeters are suitable for high velocity. The continuity equation is based on a principle of. So this is based on the principle of conservation of mass. If a fluid is flowing through the pipe and if no mass is added or removed from the pipe, then the mass at any cross section of that pipe will remain same. So this is based on the conservation of mass, that mass can neither be created or destroyed. The rate of change of moment of momentum represent. So this is based on moment of momentum principle, that torque applied by the fluid is equal to the rate of change of moment of momentum. If a liquid enter a pipe of diameter d with a velocity v, what will be its velocity at exit if the diameter reduced to 0.5 d? Means its diameter will be half. Now here, by applying the continuity equation, that is A1 V1 is equal to A2 V2. Let us say A1 V1 be the initial parameters. So area will be initially pi by 4 d square, and V1 will be the V, and at the exit the velocities will be A2 V2. A2 will be what then? Pi by 4. Here d square will become d by 2 whole square, so which can be written as d square divided by 4. So putting all these value in this equation, you will get the velocity at exit, that is 4v. For an incompressible liquid flowing in a continuous stream, total energy of the particle remains same while the particle move from one point to another point. So this statement is called as the Bernoulli equation. According to Bernoulli equation, if a fluid is flowing through a pipe, then its total energy will remain constant at any point. If we take initial point and final point, its total energy will remain same. So this is according to the Bernoulli equation. The size of the venturimeter is specified by. So here the size of the venturimeter is specified by both that pipe diameter as well as throat diameter. So this one will be the pipe diameter, and this one will be this portion, small portion will be the throat diameter. A jet of a dia discharged from 40 mm dia orifice has a dia of 32 mm at its vena contracta. The coefficient of discharge is, so here the coefficient of discharge is nothing but area of a jet at vena contracta divided by area of orifice. So simply we will take the square of diameter, all other thing will get cancelled. So area, you can take the diameter of jet at vena contracta. Diameter of jet at vena contracta is 32 mm, so 32 square divided by area of orifice, that means the diameter at orifice will be 40, so 40 square. Solving this will get 0.64 meter as the coefficient of discharge. The range of coefficient of discharge for flow nozzle is, so for flow nozzle this value will range from 0.95 to 0.98. See here, when a liquid from a tank flows through a tap, then total energy will be, so its total energy will remain constant according to Bernoulli equation. Which is the cheapest device for measuring the flow or discharge rate? So here orifice meter is the cheapest device which will be used for the measuring flow rate or discharge rate, orifice meter. So thank you for watching.